Close your eyes and imagine stepping into a candlelit laboratory centuries ago. The air is thick with mysterious vapors. Bubbling cauldrons cast dancing shadows on stone walls, and a robed figure hunches over ancient texts, searching for the greatest secret of all time. Tonight, we journey into the mystical world of alchemy. A world where science and magic intertwined, where brilliant minds pursued impossible dreams, and where the foundations of modern chemistry were born from ancient wisdom. This is not just a story of failed experiments or deluded dreamers chasing fool's gold. This is the tale of humanity's greatest intellectual adventure, a quest that spanned continents and centuries, and ultimately revealed profound truths about the nature of matter itself. For over 2,000 years, alchemists worked in secret, developing techniques, discovering elements, and laying the groundwork for our modern understanding of chemistry. They sought three legendary goals: the philosopher's stone, the elixir of life, and the transmutation of base metals into gold. But as we'll discover tonight, their real achievements were far more valuable than gold. So settle in, let the mysteries unfold, and prepare to explore the ancient art that became modern science. Our story begins in the ancient world, where the line between magic and science was beautifully blurred. In the temples of Egypt, priests worked with metals and minerals, not just for religious ceremonies, but to understand the very essence of transformation. The Egyptians were master metalworkers. They could extract gold from ore, create bronze from copper and tin, and transform simple sand into brilliant glass. To the ancient mind, these transformations seemed magical. If you could turn sand into glass, why not lead into gold? The word alchemy itself comes from the Arabic alchemia, which may derive from the ancient Egyptian word for black earth, chem. This black, fertile soil of the Nile Delta was seen as a source of transformation, where seeds became plants and life emerged from apparent death. But it was in the great library of Alexandria where alchemy truly began to flourish. Here, Greek philosophy met Egyptian practical knowledge, and something entirely new was born. Scholars like Zosimus of Panopolis began writing detailed accounts of chemical processes and equipment. These early alchemists believed that all matter was composed of fundamental principles, the four elements of earth, air, fire, and water, combined with mystical qualities like sulfur and mercury. They saw the universe as alive, constantly changing, with the potential for any substance to become any other. The ancient alchemists developed remarkable techniques: distillation, calcination, dissolution, sublimation. They created the first chemical laboratories, invented apparatus we still use today, and began the systematic study of chemical reactions. Their quest for transformation led them to discover the language of chemistry itself. In the 8th century, in the bustling cities of Baghdad and Damascus, alchemy underwent a revolutionary transformation. Islamic scholars had preserved and translated the works of ancient Greek and Egyptian alchemists, but they didn't stop there. They began to experiment, to question, and to systematize. The most influential figure was Jabir ibn Hayyan, known in the West as Jabir. Working in the court of Harun al-Rashid, Jabir transformed alchemy from mystical art into something approaching modern chemistry. He emphasized careful observation, precise measurement, and reproducible experiments. Jabir classified substances into 3 categories: spirits like mercury and sulfur that could evaporate, metals like gold and silver that could melt, and stones like salt that could be powdered. This simple classification system helped alchemists understand the behavior of different materials. In his secret laboratory, Jabir developed new techniques for purifying metals, creating acids, and working with chemical compounds. He discovered nitric acid and perfected the process of distillation. His detailed instructions were so precise that modern chemists can recreate his experiments. But Jabir also maintained the mystical tradition, writing in elaborate codes and symbols designed to hide alchemical secrets from the uninitiated. He believed that knowledge was powerful and should only be shared with those who were spiritually prepared to use it wisely. The Islamic alchemists made another crucial contribution. They began to focus on medicine. They realized that the same processes used to purify metals could be applied to healing the human body. This medical alchemy would eventually evolve into pharmacy and modern medicine. Al-Razi, another great Islamic alchemist, wrote detailed accounts of chemical equipment, laboratory procedures, and safety precautions. He classified minerals, described the properties of acids and alkalis, and developed new methods for preparing medicines. His work bridged the gap between ancient mysticism and emerging scientific method. In the 13th century, alchemy arrived in medieval Europe through translations of Arabic texts. European scholars working in monastery laboratories and royal courts began their own quest for alchemical knowledge. Roger Bacon, a Franciscan friar at Oxford, became one of Europe's first great alchemists. But Bacon brought something new, an emphasis on experimental observation that would help transform alchemy into genuine science. He insisted that knowledge must come from direct experience, not just ancient texts. In his secret laboratory, hidden beneath the university, Bacon conducted experiments with gunpowder, optics, and chemical processes. He was among the first Europeans to describe the composition of gunpowder, and he conducted detailed studies of chemical reactions. Bacon believed that alchemy could unlock the secrets of nature and provide practical benefits for humanity. He wrote about the philosopher's stone, not just as a way to make gold, but as a universal medicine that could cure all diseases and extend human life. But perhaps Bacon's greatest contribution was his insistence on the experimental method. He argued that alchemists must test their theories through careful observation, controlled experiments, and mathematical analysis. This approach would eventually become the foundation of modern science.
Another influential figure was Albertus Magnus, the teacher of Thomas Aquinas. Magnus wrote extensively about minerals, metals, and chemical processes. He distinguished between natural and artificial transformation, and argued that human art could indeed replicate the processes of nature. The medieval alchemists also developed sophisticated equipment. They created improved furnaces, more precise balances, and elaborate distillation apparatus. Their laboratories became workshops of innovation, where practical chemistry emerged from mystical traditions. But medieval alchemy was not just about chemistry. It was also about spiritual transformation. Alchemists believed that the process of purifying metals mirrored the process of purifying the soul. The work of transformation was seen as both chemical and spiritual, a quest for perfection in matter and in self. The Renaissance brought a new generation of alchemists who combined ancient wisdom with emerging scientific knowledge. The most revolutionary figure was Philippus Aureolus Paracelsus, a Swiss physician who transformed both alchemy and medicine. Paracelsus rejected the classical theory of four humors and instead proposed that disease was caused by chemical imbalances in the body. He argued that the same chemical principles used in alchemy could be applied to healing. This was the birth of chemical medicine. In his travels across Europe, Paracelsus studied with miners, metallurgists, and folk healers. He learned practical chemistry from working craftsmen and combined this knowledge with alchemical theory. He developed new medicines using antimony, mercury, and other chemical compounds. Paracelsus also revolutionized alchemical theory. He proposed that all matter was composed of three fundamental principles: sulfur representing combustibility, mercury representing volatility, and salt representing solidity. This sulfur-mercury-salt theory became the foundation of Renaissance alchemy. But Paracelsus was controversial. He publicly burned the works of ancient medical authorities and proclaimed that direct experience was more valuable than book learning. He insisted that alchemists must get their hands dirty, work with real materials, and test their theories in the laboratory. During this period, alchemy began to divide into several distinct traditions. Some alchemists continued the quest for gold, developing increasingly sophisticated theories about metallic transmutation. Others focused on medicine, creating the first chemical drugs and establishing the foundations of pharmacy. A third group pursued spiritual alchemy, seeing chemical transformation as a metaphor for personal enlightenment. These alchemists developed elaborate symbolic systems, where chemical processes represented stages of spiritual development. Their works influenced psychology, philosophy, and religious thought. Renaissance alchemists also made important practical discoveries. They developed new alloys, improved methods for extracting metals, and created the first synthetic chemicals. Their work in ceramics, metallurgy, and glassmaking drove technological innovation across Europe. The printing press allowed alchemical knowledge to spread more widely than ever before. Books of alchemical recipes, laboratory procedures, and theoretical treatises
circulated throughout Europe, creating a community of practitioners who could share discoveries and build upon each other's work. Perhaps the most surprising chapter in alchemy's history involves one of history's greatest scientists, Isaac Newton. For over 30 years, the man who discovered the laws of gravity and motion conducted secret alchemical experiments in his Cambridge laboratory. Newton's alchemical manuscripts, discovered only in the 20th century, reveal an obsession with transmutation that lasted his entire career. He copied alchemical texts, conducted thousands of experiments, and developed his own theories about the nature of matter. But Newton's alchemy was not separate from his physics. It was deeply connected. His belief that forces could act at a distance came partly from alchemical ideas about mysterious sympathies between different substances. The invisible force of gravity seemed no stranger than alchemical attractions and repulsions. In his secret laboratory, Newton worked with mercury, antimony, and other metals, seeking to understand the fundamental forces that held matter together. He believed that careful study of chemical reactions could reveal the basic structure of the physical world. Newton also studied the alchemical works of previous masters, especially a mysterious figure known as Irenaeus Philalethes. He copied recipes for the philosopher's stone and conducted experiments to test alchemical theories. His laboratory notebooks reveal a systematic approach to chemical investigation.
Other great scientists of the 17th century also practiced alchemy. Robert Boyle spent decades searching for transmutation. John Locke, the philosopher, and Christopher Wren, the architect, both conducted alchemical experiments. This was not because these men were superstitious or foolish, but because the boundary between alchemy and chemistry had not yet been clearly drawn. The same experimental methods that led to scientific breakthroughs were being applied to alchemical problems. During this period, alchemy began to evolve into recognizable chemistry. Alchemists developed more precise measurement techniques, better understanding of chemical reactions, and clearer theories about the nature of elements and compounds. The work of alchemists like Johann Joachim Becher and Georg Ernst Stahl led to the phlogiston theory, one of the first systematic attempts to explain combustion and chemical reactions. Though ultimately incorrect, it represented a crucial step toward modern chemical theory. By the 18th century, alchemy was undergoing its final transformation. The mystical elements were gradually being stripped away as experimental chemistry emerged as a distinct science. The turning point came with the work of Antoine Lavoisier, the father of modern chemistry. Lavoisier revolutionized chemistry by introducing precise measurement, careful control of experiments, and rigorous mathematical analysis. He demonstrated that matter could neither be created nor destroyed, only transformed. This conservation of mass became a fundamental principle of modern chemistry.
Lavoisier also developed the modern theory of combustion, showing that burning involved combination with oxygen, not the release of a mysterious substance called phlogiston. His careful experiments with chemical balance ended centuries of speculation about the nature of fire. But Lavoisier's work built directly on centuries of alchemical research. The experimental techniques, the laboratory equipment, the understanding of chemical processes, all had been developed by generations of alchemists. Modern chemistry was alchemy's greatest achievement. John Dalton's atomic theory provided the theoretical framework that alchemy had always lacked. By proposing that all matter was composed of indivisible atoms, Dalton explained why certain chemical reactions always occurred in fixed proportions. The discovery of new elements throughout the 19th century vindicated the alchemical belief that matter could be transformed. But instead of seeking to change lead into gold, chemists learned to understand the fundamental building blocks of all matter. Ironically, the ancient alchemical dream of transmutation was finally achieved in the 20th century. Nuclear physics demonstrated that elements could indeed be transformed into other elements. The alchemists had been right, but their methods had been wrong. Today we can actually create gold from other elements using particle accelerators, but the cost far exceeds the value of the gold produced. The alchemist's practical goal remains economically impossible, even with modern technology. As we reach the end of our alchemical journey, it's clear that the ancient art gave us far more than gold. Alchemy's true treasure was the birth of experimental science and our modern understanding of the material world. The alchemists developed the fundamental techniques of chemical analysis: distillation, crystallization, filtration, sublimation. All were perfected in alchemical laboratories. They created the basic equipment that chemists still use today: furnaces, retorts, and balances. Perhaps, more importantly, the alchemists established the experimental tradition that became the foundation of modern science. They insisted that theories must be tested, that knowledge comes from direct observation, and that nature's secrets can be unlocked through patient investigation. The alchemical quest also drove technological innovation. The search for new materials led to developments in metallurgy, ceramics, and glassmaking. Alchemical medicine evolved into modern pharmacy and the chemical industry. But alchemy's greatest gift may be its sense of wonder about the natural world. The alchemists saw transformation everywhere and believed that understanding these changes could unlock the deepest mysteries of existence itself. Tonight, as you prepare for sleep, remember that you live in a world that would amaze any ancient alchemist. We have indeed learned to transmute elements, to create new materials, and to understand the fundamental structure of matter. The philosopher's stone was never found because it was never needed. The real magic lies in understanding the extraordinary complexity and beautiful simplicity of the chemical world that surrounds us every day. Sweet dreams, knowing that you are made of elements forged in stars, transformed by countless chemical reactions, and participating in the same ancient dance of atoms that captivated alchemists for over 2,000 years.